Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so today, as you see on the screen here now, we are actually that is at the end of the topic or lecture of topic 4. Topic 4 connects with the subtopic of parabolas. Okay, so let's continue without wasting so much time. Okay, so for topics of this parabola, we are going to look into what we call the determine equation of parabola with the vertex of HK, focus, or this one here. Okay, let me call the previous knowledge. We have stated that the term of we call the value of H and K in the topic of circles and an ellipse. H and K represent the center of the conics, we call the circle and an ellipse. But then in this subtopic of parabolas, H and K represent the vertex. Okay, so it might be that you have an your dad or your parents have an astro in the house, and if the first time you see parabolas is the shape something like this. Okay, it looks like this, and it has something of an antenna here, and it located might be the wall of your house, or might be on the roof. Okay, so look at this shape here now, and this is the shape of a parabola. So then a parabola is a set of points that are equidistant from a fixed point. Equidistant means the equal distance from the fixed point of focus and from a fixed line of directrix. Okay, let P xy be the point of any point of on the parabola. So this red ink is a picture of the parabolas here, and px, any point on the parabolas. Okay, so the distance between this P to the line of directrix and the distance from P to F are equal. Okay, something like this here. Equation of parabola, the focus and P0 and directrix of x equal to negative P. Okay, so this is the line of the directrix. We call the value of the x equal to negative P here. Okay, so you have the lecture notes with you right now, so please refer to them. I'm not going to explain everything here. And they come up with us equation of y squared equal to 4px. Equation of parabolas with the vertex of v, h, and k. Okay, class. Sometimes that when we given to us any equation of parabolas, that we sometimes we get into quite confused, or what we start with the question that we cannot determine whether the graph will be facing upward or downward, facing upward to the right or facing upward to the left. Okay, so just sometimes I just use an idea of this, because most of the time we sketch the graph, or we discuss as time we call the graph of y equal to x squared. So when x to the power of 2 here, okay, we can simply sketch the graph of this with the graph of this curve, we call this curve facing upward. Okay, and then y equal to negative x squared, then the graph will facing open and facing downward. Okay, so this time now is for y squared. So then for this graph, for the equation of y minus k in bracket squared, this one will give you parabolas is either facing open to the right or open to the left. So determination of the we call the graph is whether facing open to the right, okay, the mouse here open to the right or left, is all based on the value of p here, where this p is greater than 0, it will be open to the right, and the other way around, if p is less than 0, the graph will open facing to the left. Okay, so h and k again for parabolas is not a center, just like we discussed already. We call the circle and an ellipse. For h and k in this topic of parabolas is a vertex, on a vertex here, and then this is the focus point. So the distance from this point to the focus of h plus p and k, so the distance is p. Okay, and also the distance from this point here also p. Okay, so the next picture of the this parabolas, p is less than 0 or p is negative. Okay, and the line of directrix here, which is h and h minus p. So we call the distance from this point of vertex to the point of h, and we call the focus point here, the distance is p, and also the distance from this point to the line also equal to p. And now, okay, as I mentioned just now, if given to you any equation, for parabolas, okay, I explain to you something here. For parabolas, there are only one variable, is either x or y. At one time of the equation is either x or y with a degree of 2, the highest power of 2. For circle, the equation of circle, both of x and y with the highest degree of 2. The power of x and y, which is highest, is 2. For an ellipse, we call the power of x and y both at the same time with the highest degree of 2. But for parabolas, is either one, is either x or y with a degree of 2. Okay, so as we see here now, with y to the power of 1 and x to the power of 2 here. So let's say if I come up with again y equal to x squared. So then it's the graph curve that is either facing up or facing down, open here. Okay, so for this one here now, the distance from this v, the vertex, to the focus point is p, and also we call the distance from this v to the line of this is also p, where p equal to 0. P is positive, greater than 0, then the parabolas is facing open upward here. And what about this one here now? We call this again the distance of this v to the p is f here, focus is p, and also the distance from this directrix line to the, we call the coordinate of v here, is also p. And for this one, is p which is less than 0. So the equation of parabolas in the standard form. Okay, so we have all here means that at one time the only one variable is either x or y with a degree of 2. It cannot be both and y power of 2 at the same time. No, it's only 1. Okay, so in the standard form and in general form. There you go. So determine the focus, directrix, vertex, and axis of parabola for each of the following here. Okay, so the first one, okay, what was the equation just now? The first equation here, solution for question of A, y squared equal to 16x. So we compare with the general equation we call the equation of parabola here, y minus k squared equal to 4p x minus h. So this one here, you come out with y minus 0 squared equal to 16. Okay, 16 x minus 0. And look at this one here now. We compare with this of 4p. 16 equal to 4p, then p equal to 16 divided by 4 equal to 4. Okay, now according to this one here, k and h, so it's a v of the, we call vertex of the parabola, which is 0 and 0. P equal to 4. So 0, 0 is one of the the vertex of the parabola here, and p equal to 4. Why? P is equal to 4 is positive, and look at this one here now, y to the power of 2. It's either open to the left or open to the right, but it is open to the right here because with p is positive, then it's open to the right here. Okay, so okay, now p is 4, means from 0, 0 here, we move 4 units to the right. 1, 2, 3, 4, somewhere around here. Okay, and this is the coordinate of the focus, which is 4, 0, and 4 to the right. This is the directrix, which is x equal to the line of x equal to negative 4. And this is the focus point of 0, 0, the vertex of 0, 0, sorry. And look at this one here now, the distance from the vertex to the line of directrix, 4 units to the left. And also from the vertex to the line of focus here is 4 units to the right. Okay, so this is it. The first graph of an parabola for example 1. Okay, now for example 2, b x squared equal to negative 8y. So we compare with this equation here, x minus 0 squared equal to negative 8, y minus k. So from this equation here now, h and k of the vertex is 0 and 0. Negative 8 equal to 4p, then P equal to negative A divided by 4 equal to negative 2, which is less than 0. Okay, class. We call the example of the parabola with the facing open upward or facing open downward here. Okay, this is for P which is greater than 0 and this is for P which is less than 0. P equal to negative 2, less than 0. So this is our graph. Okay, now from the information that we have just now, where the vertex is 0, 0 and the P is negative 2, okay. Then the vertex 0, 0, okay. The origin point, the vertex 0 and 0, P is negative 2, so then the focus here, the graph, this not the, we call P for negative 2, which is less than 0, tells us that the graph facing downward. Okay, and we call the distance is 2. So here with 2 units downward from 0, 0, here they come up with 0 and negative 2. This is the focus. And above, move 2 units upward here, and this is going to give you the directrix line of y equal to 2. Okay, so the solution or example for example of A and B of example 1. Okay, let's move to the next one. Okay, this is for example 2 just now. I recall show you the solution for both of A and B. So now with the second example here, determine the focus, directrix, and all the axis of our parabola. Axis of parabola for this one here now is sketch the graph. So then we compare with the, we call the equation of parabola in the standard form, y minus k squared equal to negative 4, then x minus h. According to this one here, when the vertex k equal to 2, which is y, and h equal to 0, 0 and 2, and negative 4 compared with 4p, then p equal to negative 4 divided by 4, negative 1, which is less than 0. Okay, determine the focus, directrix, vertex, and axis of the parabola. So we have found that the vertex, which is 0 and 2 above here, okay, 0 and 2, which is the vertex, and then p equal to negative 1. So y to the power of 2 is either open to the left or open to the right. Yes. For this one, when p is less than 0 or negative 1 here, is open to the left. There you go. Okay. And then, so then this is the symmetrical line of the parabola. The vertex axis of the parabola, the axis is y equal to 2, and then p equal to 1, p equal to negative 1 shows that we call the parabola facing open to the left, and the value of 1 here, from 0 to, we move 1 unit to the left, which is this is -1, so this is the coordinate of the focus, which is -1 and 2, and 1 unit to the right. And this is the value of x equal to 1. Okay, so the directrix line here with x equal to 1, the vertex here 0, 2, the focus is -1 and 2, and directrix line here x equal to 1. And we call next example here. Determine equation of the parabola described and sketch its graph. The focus of this directrix the line of y equal to 1. So the question wants us to determine an equation of the parabola. It describes here the focus and directrix line and all here. So find the equation of the parabola. Okay. The solution for example for question of A just now, given that the focus is 0 and -1 and the directrix is the line of y equal to 1. Okay, so let's sketch it so we can see clearly the picture of this graph. Okay, the focus is 0 and -1, 0 and -1 here. So this is the focus at 0 and -1. Okay, and then the directrix line is y equal to 1. Directrix line y equal to 1. Y equal to 1. There you go. So we call the distance from this point of focus 1, -1 to the directrix line of y equal to 1. So then divide by 2, and the vertex is in the middle here because the distance from the vertex to the directrix line equal to the distance of the vertex to the focus here. 1 and 1. The distance here is 1, and also the distance here equal to 1. Okay. Now, directrix of line equal to 1. So, graph. Okay, students, guys and girls. There is no such case. If this is the parabola, then the focus is outside of the parabola. Recall the point of focus point of the parabola is staying outside from the opener. We call the curve here. It's always inside. Okay, focus cannot be outside of it. It's always inside here. So if this is the parabola, the focus cannot be somewhere around here, outside here. It must inside. It's a must. Okay, this is the focus inside. So if this is the focus and directrix point, directrix line, can you recall? Can we see that this is the curve of the parabolas? No. Okay, the parabolas is somewhere around here. Sorry. Okay, there you go. So now, this is the vertex, which is 0 and 0. Okay, it's either x squared or y squared. From this curve, then we come up with x minus 0 squared equal to 4py minus 0, okay, which is x squared equal to 4p y here, And what about this one here now? For this case is, okay, we call the graph facing downward here is where P is less than 0. So the distance here is 1, so come up with negative 4 times y. Okay, and then the next question then, the vertex given there is negative 1 and negative 1, axis of parabola, is parallel to x-axis containing the point of negative 3 and 3. Okay, so it's given here, we call the information for example of B for this. Now, the vertex is negative 1 and negative 1. Okay, x negative 1 and y negative 1. So this is the vertex. Okay, the first information is that axis of the parabola is parallel to x-axis. This is an x-axis. So the axis of parabola. So it's something like this here. It's either open to the left, and this is the axis of parabola. The symmetrical to the, we call the symmetrical line of the parabola, and this line is parallel to x-axis. So the question is either the parabola is open to the left or open to the right. Which one? Okay, so that one containing the point of, okay, axis of parabola is to the x-axis and containing the point of negative 3 and 3. So negative 3 and 3 here. Okay. So guys, girls, this vertex of negative 1 and negative 1 and this point of negative 3 and 3 is one of the coordinate of the parabola. So if this the one, is either something like this or this one. It cannot be something like this because we cannot state the point of negative 3 and 3 and both of these if this is the parabola or either this one here. Okay, then because one of the point that we given here, axis is the parabola is parallel to x-axis. So which I think that is going to be something like here. Okay, sorry. Okay, this is the parabola. Okay, never mind. So now the vertex here is negative 1 and 1. So this is the symmetrical line of the parabola, and this symmetrical line is parallel to x-axis. So now we are going to find the equation of this. Okay, from this picture we can make a conclusion that is y minus k square equal to 4b and x minus h y squared. So the coordinate of vertex here, which is y minus negative 1 or y plus 1 square equal to 4b, and then x minus negative 1 here, x minus negative 1, which is x plus 1 here. Okay, so And one of the coordinate is the value that we're going to use to substitute into this equation. Y equal to 3, negative 3 here. So y equal to 3, 3 minus 1, or 3 plus 1 square equal to 4p, and x is negative 3 plus 1. So 3 plus 1 equal to 4. Negative 3 plus 1 equal to negative 2. 4 square equal to 16. 4 times negative 2 equal to negative 8p. Then p equal to 16 divided by negative 8, which is negative 2. Okay, so when p is negative 2, then we come up with we call substitute everything here into the standard equation of the parabola here, which is y minus plus 1 square equal to p is negative 2. Negative 2 times 4 equal to negative 8 x plus 1. Okay, y plus 1 in bracket square equal to negative 8 x plus 1. Okay, so expand it. Y square plus 2y plus 1 equal to negative 8x minus 8. So then y square plus 2y plus 8x, negative 8 here become positive 8, so plus 1 plus 9 equal to 0. This is the standard form of an ellipse, and this is a general equation of an ellipse. Okay, see here now, only y with a degree of 2. X, the highest is 1. Okay, so determine the equation of parabola obtained rotating the determine the equation of parabola obtained by rotating the parabola of this anti-clockwise through 90 degrees of its vertex. Okay, now class, for this question, okay, let's take a look at this one first. Where it is at? Okay, I'm just going to solve here straightly. From x squared minus 12y minus 2x plus 25 equal to 0. X squared minus 2x minus 12y plus 25. So completing the square is one of the methods to solve this. So then x squared minus 2x. Okay, never mind, I'll show you the step one by one, even though this is step that you may skip. Okay, you may ignore if you know the we call the method of complete the square easily. So x squared minus 2x plus negative 2 over 2 square minus negative 2 over 2 square minus 12y plus 25 equal to 0. So from these three, it gives you x minus 1 square minus negative 2 divided by 2, negative 1. Negative 1 square is 1. And then minus 12y plus 25 equal to 0. So 25 minus 1 equal to 24. Then x minus 1 square equal to 24, bring to the left, become negative 24. And then negative 12 will become positive. So then 12y minus 24. So then x minus 1 square, take up 12. Then y minus 2. Okay. So from here, once we compare with the standard equation of the parabola, it is x minus 1 square equal to 4p y minus k. So clearly, if we compare this equation with the standard equation of the parabola here, then the v equal to 1 and 2. Then 4p equal to 12 and p equal to 3. Okay, so now let's sketch the graph of this. Okay, it's not very straight here. Y and X. Okay, so the vertex of this is 1 and 2. This is 1, 2 here, and P equal to 3. P equal to 3, where X, the highest degree here is 2, so the graph will be facing up or facing down. But given here P is positive, so P positive, this is the 1. Facing upward here with a vertex of 1 and 2. So this is it. There you go. Okay. This is the graph. Now look at the question again. Determine the equation of parabola obtained by rotating the parabola of this. So this is we call from this equation of the parabola, then this is the picture of the parabola. We call for this equation. Rotating this parabola anti-clockwise through 90 degrees about its vertex. Okay, meaning this is the parabola and this is a vertex. So from here we rotate 90 degrees of it. Okay, so this parabola rotate 90 degrees. So you can imagine it here, maybe something like this. Okay, I'm sorry again. Sketch it nicely. Okay. Not this one, sorry. It's sometimes hard to sketch on this board. We call this board freehand. There you go. So the vertex is somewhere around here. So now from this graph, okay, this is the graph facing upward, so rotate 90 degrees anti-clockwise, then the graph will facing to the left. Okay, so 90 degrees here. So this is the new parabola here now. Okay, so look at the first parabola before it switch the position from facing upward to facing to the left. Open up left here. Okay, the vertex is 1 and 2. Okay, and then P equal to 3, positive, facing upward. And this also tells us, give us the coordinate of the focus from y equal to 2, it moved 3 units above. Okay, and this is the focus of the first parabola here, which is 1 and 5. And 3 units downward is -1 here and directrix line. So now, from here, from this parabola, it turned up to this one here with a P equal to 3, so means that from 1, it moved 3 units to the left. Okay, just now it moved 3 units above, now it moved 3 units to the left. So from 1, 0, -1, and -2. Okay, and the coordinate of this focus point here, the coordinate of this focus point, it is -2, okay, -2 and 2. And the directrix line from here, if we move 3 units to the right, 1, 2, 3, which is 4. And this is the line of the directrix for this parabola. Okay, now facing to the left, y minus the vertex here now, the vertex is still the same, 2, y minus 2 square equal to 4p and x minus 1. Okay, but then given here now is open to the left, this p is negative. Okay, for the new one here, not the first equation of the first example equation from the equation, but this one is a parabola that should be called shift after 90 degree according to the question here now. So this is the one. For this is open to the left, so then it is 4 and p is -3, and then x minus 1 equal to -12 with x minus 1. Okay, so equation here now, y minus 2 in bracket square, then -12 x minus 1. Okay, this is more than enough. And if you like to finalize your answer in the form of general equation, something like this, so that you just expand it, y squared minus 4y plus 4 equal to -12x plus 12, then y squared minus 4y plus 12x, 12 will here become negative, so 4 minus 12 minus 8 equal to 0. Okay, next. Conclusion, meaning that we're almost at the end of the topic of this, the lecture for this part here. Okay, so never mind. The standard equation of the parabola with a vertex. So y is either, you can see here now, y squared equal to 4px or x squared equal to 4py. And the standard equation with the vertex of h and k, again for the parabola, h and k is not the center, but is the vertex. Okay. So then class again, for y squared is either open to the left, the graph is either open to the left or open to the right. And for x squared is either open facing upward or facing downward. Okay, and general equation of parabola is either y with a degree of 2, the highest degree of 2, or x with the highest degree of 2 at one time. It cannot be both of x and y with a degree of 2 at one time. No. Okay, it's only one. Okay, so vertex origin point here. Okay, just refer to your lecture notes of this. Okay, again, that's what I told you just now. The distance from the vertex to the focus and to the directrix line are equal. Okay, for p greater than 0 is open to the right, and for p less than 0, then the graph is facing open to the left. Okay, that's it. Okay. Because we are repeating the same recall from the beginning of the topic of this lecture, so I just think that we're not going to waste so much time discuss all this again. Okay. That's all things that you need to remember for this topic of subtopic of parabolas for topic 4. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day. Thank you.